These are questions out of the Delta textbook, second edition, exercise 4.5, questions 1, 2 and 3 on locus. Now the first question asks for the points of the locus that is at a distance always of 5 units from the main point 0, 0. So it's starting here at the origin. And what it means is you take any point on the outside and that distance there has to be 5. So if you look at that all the way around, that distance has to be 5. And this distance has to be 5. And if you keep on doing that all the way around, what you end up with is just a circle. So the locus of points about a fixed point where the distance is set is the equation of the circle. So this is just x squared plus y squared equals 5. And you can see that because basically this is a whole lot of triangles. So I could take any point along there, and then that would be my y value, and that there would be my x value, and I know by Pythagoras that x squared plus y squared equals 5 squared. Sorry, it's x squared plus y squared equals 5 squared. So that's the equation of a circle. Now if I just move one, so I'm at 3, negative 2, that means I'm down here, and it is 3. All it means is that that's the center of my circle is now here, and I'm going to go up 3 and down 3 and across. It's just a circle centered on this point here. And from when we did circles last year, we know that it is just x minus your x value, which happens to be 3, plus y minus your y value. Y minus minus 2 is plus 2. Each of those is squared, equals my radius squared, which happens to be 3 squared. So each of these locus are just circles. So whenever you've got a locus of points which is a fixed distance away, all you've got is a circle. Right, the next question talks about the locus of points that are equidistant, or the same distance between 2 points. So we've got these 2 points here and here, and we've got the set of points that are exactly the same distance away. So if it was here, that would also be exactly the same distance away. If it was here, it's right in the middle, exactly the same distance away. If we joined up all these points, we would actually get the perpendicular bisector of the line joining the 2 points. So when we were up here, this is just a circle. Now if we've got the locus between 2 points, this is the perpendicular bisector. I'll go over the algebra of exactly how you come up with the equation of those lines, and also how you can do this as well, just using Pythagoras. It's exactly the same thing here, we just use Pythagoras for it. Right, if we are given 2 fixed points, and we're told that the distance to another point, the locus of points, of one to the other, of that distance there, S1 plus S2 plus S2. So I've got that S1 plus S2 has got to equal some kind of constant. This is like having 2 pins in a board and a big long piece of string. Now you know, if you've got a long piece of string with 2 pins, what you actually end up creating, if you've ever tried this, is actually an ellipse. So at the moment I'll go over the algebra of that as well sometime in class, but all I really want you to see is if you've got the sum of 2 distances to a point, you get an ellipse. If you have got the set of locus, or the set of points that are equidistant from 2 points, you have a perpendicular bisector. If you have a point, a fixed point, and then you want all of them exactly a fixed distance away, like 5 centimeters away or 5 units away, you have a circle.